Hello guys, this is Prabhanshu Yadav and I'm here again with the periodic classification of the elements part 2. In the previous classes, we have studied about the Dobnius triads, the Mendel's periodic table and the Newland's octaves. Now we'll be studying about the modern periodic table. The contents of the modern periodic table are the introduction to the modern periodic table, characteristics of the periods, characteristics of the groups and the merits and the advantages of the periodic table. Now as we see, this is the periodic table. You can see the periods. There are 7 periods and 18 groups, and you can see different elements being arranged in these periods and groups, and in total we have the 118 elements. Now what do you understand by the modern periodic table? The modern periodic table was prepared by Niels Bohr. The elements were arranged on the basis of their increasing atomic number. As we know, the elements were arranged on their basis of their increasing atomic number. Now we know that the atomic number is the number of electrons or the number of protons of the element. So on that basis, the electronic configuration was figured out, and on that basis, the elements were arranged in the modern periodic table. Now, as we see, the atomic shells have been given here. Inside the nucleus, the atom has a nucleus, and that nucleus, out of which have the electronic shells revolving around it. So we can see the nucleus has a positive charge because it is made up of protons and neutrons. And we see the shells K, L, M and different shells with the different numbers 1, 2, 3, 4 and different numbers of electrons revolve in them. Now as we see, I am giving you the electronic configuration. We see the name of the shells are given K, L, M and N, and the number of shells are given by 1, 2, 3, 4. The formula for generally calculating the number of electrons present in those shells is 2n square. So as we place the value of n, we go on to find out that there are 2, 8, 18, 32 and so on electrons placed in different shells. Now the octet rule. The octet rule says that every element has to attain stability either by losing or gaining electrons so that it attains the configuration of the outermost shell like that of a nearest noble gas. That is, it completes its octet. Even after following the rule of the 2, 8, 18, 32, it has to configure its valence shell like that of the noble gas. As we know, the elements have different of electrons in their valence shell. It might be 1, 2, 3. As we know about the sodium, the electronic configuration of sodium is 2, 8, 1. So it has to lose the 1 electron so as to attain its electronic configuration like that of the nearest noble gas, which is neon. Okay. So as we move in the group on the periods, we see the elements have to get their electronic configuration like that of the nearest noble gas. Now here is the table. I am giving you this table. It will be really helpful to you. You can see the elements up to calcium. I have placed the calcium. I have given the name of the elements. I have given you the atomic number, the electronic configuration, and I have given you the valencies of the elements. And moving further, you can see the other elements also. They have their electronic configuration and the valencies. This will be really helpful for all of us so that we can easily configure out the electronic configuration and figure it out, okay, how many elements are there or the electrons are there in the K, L, M and shells and the valencies of these elements. Now the characteristics of periods. The characteristics of periods are as we go. The first one is the valence electrons. On going from left to right in a periodic table, the valence electrons of elements increases from 1 to 8. Now the valency, on going from left to right in a periodic table, the valency of element increases from 1 to 4 and then decreases to 0. I'll be explaining this point afterwards. First I'm giving you the points. Size of atoms, on moving from left to right in a periodic table, the size of atom decreases. The metallic character, on moving from left to right in a periodic table, the metallic character decreases but the non-metallic character increases. Chemical reactivity, on moving from left to right in a periodic table, the chemical reactivity decreases and then increases. Nature of oxides, on moving from left to right in a modern periodic table, the basic nature of oxide decreases and acidic nature of the oxide increases. Now here I am giving you 2 periods. The 2 periods, as we see, are beginning with lithium, beryllium, ending on neon, and beginning with sodium and ending on argon. Now the first thing was that the valence electrons, if you see the electronic configuration of sodium as the chart I have given to you, you must have seen the electronic configuration of sodium. It was 281. The valence electrons in the outermost shell was 1. As we go on to magnesium, it was 2. As we go on to aluminum, it was 3. Like that, the number of valence electrons goes on increasing as we move across the period from 1 to 8. Now the valency also. See, the valency of sodium is +1 because it can lose an electron very easily. So for that, the magnesium also has the +2 valency. It can also lose. Aluminum can also lose. Silicon has dual valency. It can lose or either gain. But when we come to phosphorus, it has the ability to gain because it is a non-metal. So it will be gaining the electrons so as to attain its electronic configuration like that of the nearest noble gas. So what do you understand by this? they have to attain the nearest noble gas configuration. So either they will be losing the electron or they'll be gaining the electrons. Now we are further moving to the metallic character. If I tell you the metallic character, sodium is the most metallic element and chlorine is the most non-metallic element. As it said, the electronic configuration, you can see it. Now the metallic character goes on to decrease when we go across the period, and the non-metallic character goes on to increase. Why does it happen? The reason behind is that sodium has 1 electron in the outermost shell and magnesium has 2 electrons in the outermost shell. So losing electrons will be much easier, or sharing electrons will be much easier for these elements. But as we go on to aluminum, the metallic character goes on decreasing because sodium can easily lose 1 electron and aluminum takes a lot of time to lose that electron. Now coming to the silicon, phosphorus, sulfur and chlorine, you can see that chlorine needs 1 electron, so it has a tendency to gain an electron very readily. Now moving to the characteristics of the group, valence electrons, all the elements in the group have the same number of valence electrons. As we know, the elements of the first group have hydrogen, lithium, sodium, potassium, and you can see that they have the common electron in their outermost shell, the same number of electrons in the outermost shell. The valency of the elements in the group have same valency. The size of the atom on going down the group, the size of the atom increases. Why does it increases? It increases because the number of electron shells goes on increasing. That's why the atomic radius also increases. So the size of the atom increases. The metallic character on going down the group, the metallic character increases. Why does it increases? The reason behind is that potassium is highly reactive. The reason is that its outermost electron is far away from the nucleus. So it cannot get hold of that electron and he can easily lose that electron. So that's why potassium is more reactive. The chemical reactivity increases on going down the group for the metals, as I've told you, but for the chemical reactivity of the non-metals decreases. Why does it decreases? Because of the increasing of the number of shells. The nucleus goes down inside the atom and it has no reactivity, you can say, or no tendency to catch the electrons very readily. Now moving further, as I have shown you, this was the group and which I have given you the explanation. Now the merits of the periodic table, it is based in the atomic number, which is the most fundamental property of the element. Others were placing on the increasing of the atomic number, but the physical properties also. But this has explained us that the basics of the atomic number, the fundamental property. Now it explains why the properties of element repeat after the configuration of 2, 8, 18, 32. As we know, the electronic configuration 2, 8, 18, 32 repeats, so the properties of the elements also repeat. It is easy to remember the properties of the elements, the type of the compounds formed by an element, and can be picked up by knowing the position of the elements. So guys, I think this video will help you out. I have given abundance of things in this video and will meet you again. Thank you so much.